Hi everybody, welcome to my talk. This is Baby's First 100 MLSec Words. My name is Erick Galinkin. I'm an artificial intelligence researcher at Rapid7. I specialize in breaking machine learning stuff and applying machine learning to detecting bad things. I also do research at the Montreal AI Ethics Institute on applying DevOps principle to machine learning ethics. And last year I was here at DEF CON in person, not here in my house at DEF CON, presenting at the Cloud Village on a piece of malware that I wrote. Malware, not actually malware, just in case the legal team is listening. And I presented that piece of proof of concept malware called Sassy Boy. But mostly I do boring math stuff. And if you can't see my speaker video for some reason, I put a picture of my face on the right so that you can see it, or you can see it twice. You can see that my hair hasn't changed basically at all in years. So before we get started, let's just answer the question, what is MLSec? Because I get asked that a lot by practitioners in security and in machine learning, honestly. And mostly it's an argument, and it's an argument between three groups of people, as it usually is. And the first group of people is people who think it's only applications of machine learning and artificial intelligence to security problems. So that's automated malware detection, that's next generation SIMs, that's automated red teaming, and that sort of stuff. And then there are people who think that it's just securing artificial intelligence in machine learning systems. And then there are those of us who are correct, who think it's both. It's kind of any intersection of artificial intelligence, right, that broad category of machine learning / AI, and security. And since this is my talk, and since I am the Mao Zedong of MLSec, I get to decide that it's both. And if anybody argues with you, or you hear anybody having this totally asinine argument, you can just tell them that I said it's both, and then the argument can be over and everybody can do more productive things with their lives. So we'll start with deepfakes, and right, so D is for deepfakes. And this man on the right, if I didn't have a speaker video, I probably could have just put that picture up and said it was me. And everybody would have believed it because he's got kind of scruff. He looks like the kind of guy, right? And I'm allowed to say that because he's not real. This is not a real person. This is completely an AI-generated image. And so, to give deepfakes a real definition, they're a convincing synthetic image, video, or audio recording which purports to be real. So, I'm pretty convinced by this picture. If I saw it in the wild, right, if somebody put it as like their Twitter avatar and was like, yeah, I am a software engineer at Google, I could buy that. I could buy that based on this image, right? We have our stereotypes, right? The thin-rimmed glasses, the scruff, and it's super convincing. It's super convincing. And I think that's really, like, when we think about impact, that's what it is. It's that they're convincing to users. So we also see deepfakes in the text generation space, where it purports to be a real email, or we see deepfake writing, which mimics the style of famous authors. We see deepfake audio recordings, which sound like the person who they are trained to sound like. There's a piece of commercial software out there called Lyrebird, which does this really well. And so, they're very convincing to users. And as a result, they get used widely and they're easy to make, right? That's the other thing, is they don't take as much time as finding and crafting an image, or carefully learning a style, or mimicking a voice, right? You just kind of train the model and push them out. So they're easy to make and they're convincing to users, which means that they can have real impact but that impact is mostly societal, right? So there was a famous, semi-viral video of Jordan Peele doing a deep fake where it was an image of President Obama speaking, and you can look it up. It's really easy to find. And so like the risk there is really that broad swaths of people will believe that a doctored or deep faked video is real. And so if there's something like President Donald J. Trump, declaring war on North Korea on a hot mic, or suggesting that he might invade North Korea on a hot mic, that could be really convincing to people. And so that's the real risk of deep fakes, is that they are a powerful disinformation tool, which is powered by artificial intelligence. And so, our mitigation against deep fakes is kind of, there's very little we can do about deep fakes. They're difficult to detect, they're very convincing to users, they're easy to make, and so really it's a broader social problem that we need to tackle, of having people be inherently less trustful of information sources and really vet where they get their information from, which is a hard problem. But this isn't an enterprise security threat. This is a social threat. So moving back to thinking about deployed models, we'll look at adversarial examples. And this GIF over here on the right is from a pretty well-known example that was really, really hyped up, and it was the turtle rifle paper, because the Google computer vision API is what they attacked, and they 3D printed a turtle. And this is pretty obviously a turtle to anybody watching who isn't powered by the Google Vision API. And if you are an artificial intelligence powered by the Google Vision API, I'm so sorry for the rest of this talk, because you're not going to like it. It's an input to the classifier that's specifically crafted to force misclassification. And so this object as a turtle, just a little toy turtle, right? Being misclassified as a rifle, the risk there is if you have a CCTV system that's powered by Google Vision API, which seems reasonable to license, that's looking for potential security threats, and you don't input all of that racist physiognomy that we already see in a lot of those systems, but instead just say, let's just look for weapons. Well, this could falsely trigger those systems, and so there's a risk there too. And correspondingly, if you 3D printed a gun, right, that got misclassified as a turtle, that would also be a threat. Right? So the impact really is that it causes misclassification. And so that real world security threat, and 3D printed examples are really rare, and they're really difficult to do. And they don't tend to work in all situations, and any researcher in computer vision can explain to you why it's not a real part of the threat model, and that's fine. But our threat is that it causes misclassification. And as security practitioners, right, we try to look for ways to use technologies to detect bad things. And so if you integrate artificial intelligence into your malware detector, for example, an attacker can bypass detection using adversarial examples. And the thing with adversarial examples is when we think about how to mitigate them, one of the only truly effective ways to do it is through what's called adversarial training, where you basically show it a bunch of adversarial examples and tell it no, classify these correctly. And that's really time consuming, and it's expensive, and it's hard. And so not a lot of people do it. And it requires you to take your model out of production and put it back into training, which again has a business impact. So one of the other ways to sort of mitigate it is through what's called ensembling, where you don't just take one canonical model, you take several models and sort of average their output, or take a weighted average of their output or whatever. And so that's another way to do it. And that's kind of because it's a lot harder to come up with an adversarial example that works across a variety of classifiers, especially if they're not trained on the same data, if they don't have the same architecture. And it's still possible to do, but it sort of raises that barrier to entry. And if we think about it in terms of like cryptography, that's really what we're trying to do, right? Is we know that there is hypothetically always an attack, right? You can brute force the key space. That's a hypothetically feasible attack against AES, right? But it's good enough, and it takes long enough to brute force that key space that, it's fine. It does the job, right? And that's sort of the same thing here, is you just have to raise that barrier to entry to make it not worth it for an attacker. So the next thing we want to talk about in terms of threats to deployed models are backdoors. And so backdoors in a machine learning context are manipulations of trained model weights that result in a specific outcome each time. So a common way to do this in neural networks is bias poisoning, where you take one class and you make the bias for that one class in just the output layer really, really, really big. And so you're only changing one weight in the whole network, so it doesn't change a lot, right? But by virtue of making that weight really big, you'll always get the same classification. And if it's a binary classifier, right, say it's, again, our malware detector, because people love to make neural network powered malware detectors for whatever reason, and I've made one, so I'm allowed to criticize. People love to do it, and that's a really easy way to just be like, nope, everything's benign all the time, always, 100% of the time. So, the impact is that it causes misclassification. And I say, but not really, because really what it does is remove a class or remove all other classes from the classifier. So it's not really misclassification. It's just making it a one class classifier. And our mitigation is like, just don't let attackers get access to your model. And by your model, I mean the trained model weights. And I say this kind of flippantly, because if an attacker has the ability to manipulate your model weights where you're hosting your model, they can do way worse things than backdoor your model. So it's like a local privilege escalation that requires you to have admin to begin with. It's not really a threat. So again, attacks against deployed models. There's model theft, and I want to talk about model theft and give a lot of credit to Will Pierce, formerly of Silent Break Security, who I stole this graphic from his fantastic DerbyCon presentation last year. Was given the first CVE for machine learning, which is super dope. And so model theft is the process of creating a copycat model by querying a trained model, right? So essentially what we're doing is we're hitting a model over and over and over again. And using the outputs of that trained model, we train our own model to give us an approximation of that model. So, if you have a box and you put in a 1 and you get out a 2, and then you have a second box, you want to put in the same input and get the same output, right? And it doesn't really matter what happens inside of that box as much as it matters that whatever input you give it, you get the same output. And that's what happens with model theft. So our impact here is kind of twofold. And so the potential for adversarial attacks in model theft goes way up, because somebody has a model they can specifically query against to validate whether or not it gets misclassified without interacting with your model. So it gives them sort of a private development environment for these adversarial attacks. And that's what Will did in the proof pudding, is he created this copycat model so that he could test phishing emails to bypass the Proofpoint email security appliance. And it was incredibly clever, super dope. I recommend watching his talk. But after you watch all the other talks at the AI Village, maybe like after DEF CON, watch it. It's a really good talk. The other impact, though, is the loss of intellectual property. So one of the things that I think kind of got overlooked in how cool the ability to bypass security appliances is that if you hire a bunch of data scientists and collect a bunch of data and clean a bunch of data and spend years creating and building and deploying a model that really differentiates you from the competition, and some unscrupulous company in not Canada, steals your model, approximates your model, and just shoves it into their product and says, yeah, we do the same thing. Well, it costs them a lot less money to just copy your model. It costs them almost nothing in the grand scheme of things to copy your model. And so there's no moat, so to speak. So it really hurts your ability to create a differentiated product. So this is a real vulnerability from that standpoint. And we'll get one layer deeper in our next slide. So when we think about mitigations for model theft, right, there's two. And the first one is limiting queries to the model. And this one kind of feels bad because you don't want to limit queries to your model too much, since most queries to your model are going to be legitimate. For the most part, you're expecting these inputs and giving outputs, and you created this model and you're hosting this model because it's supposed to be useful to someone. And for most people, because of just the corporatization of information security and the corporatization of artificial intelligence, it's probably the people who pay your paycheck who want this. And so inherently you want to have really, really high uptime. But you want to balance that really high uptime and the fact that there may be a single endpoint that's making a lot of legitimate queries to your model with the fact that there may be an attacker who's trying to use your model for evil, trying to steal your model. And so the other thing we can do is limiting information returned from the model. And we saw the efficacy of this with SQL injection, where like back in the olden days, a million years ago, because it's 2020, and so time doesn't matter anymore, we would return these detailed error messages for SQL queries. And it made it really, really easy for attackers to find the information they were looking for in SQL databases, especially SQL databases that didn't do a great job of input validation. And so, once we started returning, basically, there was an error as the error message, it became much harder, right? And it's still feasible to do, but it became much harder. And it's similar here. If all that was returned was a blocked or not blocked, that binary signal versus a detailed header, then it would be much more difficult to create a copycat model. And so, that is a real mitigation. And when we think about model theft, kind of the next step is inversion, model inversion. And what model inversion is recovering training data from a trained model. So there was a paper by Nick Carlini that came out 2 years ago, I think, in 2018, about how neural networks unintentionally memorize specific training examples. There have been papers on model inversion, both traditional and using generative adversarial networks that have shown that it's pretty effective. And so the impact here is the loss of data, right? You're losing training data. And maybe that doesn't matter a ton. So like at Rapid7, we have our open data set, right? And that's free and open for anyone to use for non-commercial purposes. And we make it available for, other stuff, right? And so like if our model was trained on open data and somebody inverted our model, we probably wouldn't care that much because like that data's out there, right? But if you are training a model for like a large medical device manufacturer and it's trained on sensitive medical information, and that information gets recovered, well, that's a lot worse. If you're a data scientist at Equifax or some other credit rating bureau and you have a bunch of sensitive financial data that you train a model on, that's pretty terrifying, right? The penalties for losing everybody's data at Equifax could be huge. You could have to pay a bunch of people's credit monitoring service for a while. And that would be bad for your business. So when we think about mitigations, really the first one is to protect access to the model. So if they have direct access to the model, it's much easier to do inversion. It's much, much easier to do inversion. There are different techniques you can use if you have direct access to the model. And then the other mitigations for model inversion are essentially don't let people steal your model, because then it's easier to use it as sort of the discriminator in the GAN. And the architecture is a little more complicated than a traditional generative adversarial network, but the idea is pretty similar. You basically show it an example and say, does this look familiar? And it goes yes or no. And if it says yes, then you may have inverted the information. So our next threat is poisoning, data poisoning. And data poisoning is when malicious users inject bad training data into a model to corrupt it. So usually this happens in online learning, where the model is continuously trained on the input to the model. And that is definitely a threat that needs to be considered. The other option is that they can get access to wherever you store your data and just inject bad examples. So our impact is misclassification. It sort of shifts our decision boundary to deliberately misclassify samples. So, letting spam through because now your threshold for what is spam is so high because you've just been doing online learning, right? And so when we mitigate it, right, we want to go back and think about protecting access to our data. So we want data integrity, right? So having data versioning is really important, making sure that your training data has a version, has an associated hash, has a label. That's super important. And then our next is we don't want to just allow unvalidated, untrusted input to our model. That's something we see a ton, is people who just accept whatever input with no validation on the front end. It's just whatever gets input to the API gets pushed into the model. And that can really cause problems when you're retraining if you just take, those inputs that you get and sort of store them off for training later. So, we're coming up on the end of this talk, and so we want to talk about what can I do, right? And this is sort of a choose your own adventure story. It depends on your role. So if you're a hacker, and by hacker I mean this in the colloquial sense, like a black hat, or a red teamer, right? Black hats are already doing some of this stuff. So I really mean, if you're a red teamer, if you're catching up to the elite APT black hat hackers, right? Take advantage of the lack of defenses on machine learning systems. Microsoft put out a report earlier this year saying that in their survey of large companies and government organizations, out of, I think it was 28, only 3 had any meaningful defenses on their machine learning systems. So if you're a red teamer, like, check it out. If you're a vulnerability discovery person, like, check it out. You could definitely find stuff. And that's because nobody knows what you're doing, and nobody's looking for you, right? Nobody is looking for black hat hackers, right? APTs, whoever, right? Nobody's looking for threat actors in their machine learning systems today, at least nobody that I'm aware of. And if you are, let me know, yell at me in the Discord, and I'll be like, oh, damn, cool. If you're a defender, if you're a blue teamer, right? If you're a sock monkey, if you're a researcher, if you're at DEF CON, you're probably one of these 2 categories. Test your machine learning systems as if they're part of your infrastructure. So what we see a lot is that machine learning engineers and data scientists develop these models, and they take these models in like a .py file, and they hand it off to engineering, and engineering goes, I don't know what this is, and they slap a Django API in front of it and put it in a Docker container, and then just deploy it in Kubernetes as an API. And then when InfoSec looks at it, they go, I don't know what this is. It's magic. You put in JSON and you get an output. It's magic, and we don't mess with it. And that sucks. Don't do that. Don't do that. Test your systems. Test the machine learning systems. Work with your data scientists. Work with your ops people, because this is part of your attack surface. This is part of your attack surface, right? And don't let people hype you up over AI-generated phishing emails. When GPT-2 came out, people went nuts and were like, this is the end of detecting phishing. They're going to be too convincing. And like, just don't, okay? It's the same thing that we've been saying for 20 years. Patch your systems. Look for bad stuff and patch your systems. That's it. There's nothing new under the sun. It's the exact same thing we've been saying for 20 years. Just keep looking for bad stuff and patch your systems. And if anybody gives you pushback on patching your systems, like, have them talk to me and I'll yell at them for you, because you have to patch your systems. If you're watching this talk and you're a data scientist or a machine learning engineer, first of all, thank you for coming to DEF CON. DEF CON is dope. And like, even though it's free and remote this year, come back next year, because it's cool. Conduct threat modeling on your models. So before you put a model into deployment, work with your InfoSec team, work with ops, and sort of ask, like, what could go wrong, right? What are the risks of an adversarial attack on this? What are the risks associated with this particular model, and what is the attack surface of this model? And also when you're deploying those models, work with InfoSec and ops to balance uptime with the risk of model theft. These 2 kind of go hand in hand. Is like, you're going to deploy these models. Somebody may try to steal them. Is there a risk if somebody steals your model? Like, does it matter? And if it doesn't matter, like, think about, would it be okay to publish the source code and data for this model? And if your answer to that is no, then you really need to make sure that InfoSec and operations are aware at deployment time. And finally, don't hype people up over text generation models. Like, GPT-2 and GPT-3 are super cool from an NLP standpoint, natural language processing. But like, they're not going to change the security landscape. Stop scaring people, please. I'm literally begging you, don't hype people up over text generation models. Here are some references. These are some of the things I talked about. And thank you so much for attending my talk. I'll be in the Discord most of the weekend, so if you have any questions, feel free to drop me a line. Thank you so much. Have a great weekend. Enjoy your con.